Hi, let's look at this op-amp circuit in the upper left part of the screen. This is what's called a voltage follower. And voltage follower would be a circuit where the output voltage follows the input voltage. So here the input voltage is connected to the positive terminal of the op-amp, and the negative input to the op-amp is connected directly to the output. Now this connection from the output back to the input is called feedback, and in this case it's called negative feedback because it's connected to the negative input terminal on the op-amp. Now what we want to do is solve this circuit, and solving usually means finding the output voltage as a function of the input voltage. To do that, we're going to use the ideal op-amp model shown on the right, and here I've got a voltage source which has a high gain A, a high amplification factor, and that amplification factor is multiplied against the difference of the voltage at the positive input, subtracting the voltage at the negative input. In other words, the gain multiplied by the differential input voltage. So this is the ideal op-amp model, and we can use that here. And so my output voltage is then given to me by the ideal model. Now, again, I need to find the output voltage in terms of the input voltage, so I want to eliminate these terms V plus and V minus by replacing them either terms that involve the input voltage, VI, or the output voltage, VO. So here, the input voltage, VI, is directly connected to the plus terminal, so what that means is VI equals V plus, and then here the V minus term, or the V minus voltage, is connected directly to the output voltage, so my output voltage equals V minus. Now I substitute in the equation above to eliminate V plus and V minus using these two equations that I got directly from the circuit, the upper left, when using the ideal model. So my output voltage is the gain multiplied by V plus, but V plus is the input voltage VI. So substitute that in. And the second substitution is for V minus, and what we have shown is V minus is the same as the output voltage, so substitute in the output voltage. Now I want to gather terms, so let's put the output voltages on the left and the input voltage on the right. But okay, before we do that, let's go ahead and multiply through by A. Okay, now gather the terms on the left. And gather the input voltages on the right. Factor out the output voltage on the left. Now I'm going to divide both sides of this equation by the gain A. This will make it a little bit easier to see the relationship between the input and output voltage. So divide both sides by A. Of course, the A's cancel here, and they cancel here. So that's going to leave me with this equation. 1 plus 1 over A multiplied by the output voltage equals the input voltage. Now again, we want to solve for the output voltage, so let's divide both sides by this term, 1 plus 1 over A. So then that gives me the output voltage 1 over 1 plus 1 over A times the input voltage. And this then is the equation, or the relationship that we're looking for between the output voltage and the input voltage. And here, as you can see, as the value of A is large, this term goes to 0, and then your output voltage tracks the input voltage. And you can also see the value of A could vary quite a bit, and that equation, that relationship between the output voltage and the input voltage would still be true. So even if A was as small as 100, the output voltage would be within 1% of the input voltage. And typical values of A might range from 10 to the 4th, 10 to the 5th, 10 to the 6th. So they're really quite large. And so this becomes a very good connection between the output voltage and the input voltage, and essentially they are the same. That is the voltage follower circuit.